Hello everyone. Today I thought to discuss with you regarding the problem solving tools. This is very important because in our day-to-day life, we are facing to several problems and we are solving the several problems also. So before discuss with about the problem solving tools, I just thought to little bit discuss about what is the problem. Okay. So simply we can write down this formula equation. Problem equal expectation minus actual. So that means if there is any deviation from the expectation to actual, so that is called problem. So I just put in here simply problem is deviation from normal, expectation, and the standard. So someone can put standard into here rather than putting the expectation. Someone can think, okay, the problem is normal, a deviation between normal to actual. All those are correct. If what you have got is not what you have expected or wants, it is problem. So that is the theoretical explanation about the problem. So now I am moving to next slide. Okay. Why problem solving tools? That is also important. Okay. Now you can see here, problem solving may unfold differently depending on the industry. So when we talk about the industry, it may be manufacturing, it may be service sector, it may be in a banking sector, okay, whatever the place. So industry to industry, location to location, environment to environment, the problem is different. When we talk about the same organization, even the department, different department, they may have different problems. So we have to understand that. But most of us will agree that before you fix any issue, you need to be clear on what it is, why it is happening, and what your ideal long-term solution to achieve. So that is the important case. Understanding the both the nature and the cause of a problem is the only way to figure out which action will help you to resolve it. So we have to understand the nature of the problem as well as we have to understand the causes of the problem. So if you want to understand the nature of the problem and causes of problem, thus you must have a standard mechanism to identify root causes and analyze the countermeasures in a proper manner. Because of that, we want problem-solving tools. In the management, okay, there are 7 major tools. Also, I have included in here, okay, histogram, Pareto chart, cause and effect diagram, defect concentration diagram, control charts, scatter diagram, etc. These are, some people call these are as a quality tools. Some people telling these problem solving tools. Actually, I would like to tell, okay, I'm talking about the problem solving. Yeah, that's correct. But I would like to tell these are problem analyzing tool. So if we want to drive for the solution, first we have to analyze the problem. So we can use these all tools to analyze the problem, to find out the causes and understand the nature of the problem. That is also very important. Okay. So today my expectation is I just introduce all these 7 tools. Separately, I have done videos regarding each elements, but in this video, I'm going to explain you briefly what are the 7 type of problem analyzing tools. We'll go one by one. Okay. Histogram. Please see the definition. Histograms are a useful way to illustrate the frequency distribution of continuous data. So histogram is an illustration. You just think if you have lot of individual data, it is very difficult to take some idea. So from the histogram, what we are going to do, we are preparing the classes and we are going to illustrate the frequency distribution based on that class. Okay, that is the aim of histogram. Now you can see, okay, this is just simple example. These are the classes. Okay, you can see. Actually, I took as example the lung volumes of people, student, maybe. Okay, so these are the classes. I already prepared the classes 2.5 to 3 liters, 3 to 3.5, 3.5 to 4, 4 to 4.5, like that. In here, I am putting the frequencies. Frequencies mean how much time this happened. If not, how many members in the class we can include into this class. Okay, so in here classes, in here frequencies. Now, what are the class width? Class width means the difference between that first number and the last number. As example in here, okay, as example in here, when we deduct 2.5 from the 3, okay, so what is the class width? 0.5. As example, when I take in here, what is the class width? It is also 0.5. In here also 0.5. So now you can understand the class width of all the classes in this example same. And also you see, when we consider the first class, it is end up with 3, then the next class start with the 3. That is end up with 3.5. Next class start with 3.5. So that means this is continuous data and equal class. So histogram also, there are different types. So this is actually, I am typing here, the first type of the histogram is continuous data and equal class width. Equal class width. Continuous data and equal class width. Okay, then we can draw this histogram like this. It is like a bar chart, but we have to understand in between two bars, no any space, because this is continuous data. So this is the illustration. You can see the lung volumes we are taking into the x-axis. Every time frequency we are taking into the y-axis. So this is the histogram. Now it is very clear. I can understand. Then lung volumes liters from 4 to 4.5, there are maybe 11 members according to this frequency axis. Okay? Something like that. So this is the simple illustration. Then, okay, you can see the vertical axis represent the frequency. The horizontal axis represent the lung volumes in liters. There are no gaps between the bars because data are continuous. That is also very important. Remember to give your histogram title. Please understand, when we draw the histogram, we have to give the title for the histogram. That is also required thing. Now, when we connect the midpoint of each and every bar, that is called frequency distribution. This is the frequency distribution. Also, I would like to add, if you want, that is also good, we can connect this endpoint to the middle part of the horizontal axis also. So this is the frequency distribution. We can tell this is frequency polygon also. This is the first type of histogram. So I'm moving to next one. In here, okay, just see, this is also continuous data. Why I'm telling this is continuous data? It starts from 2, end up with the 3. Then the next class is start with the 3, end up with 3.2. The third class is start with 3.2, 3.5, 3.5, 4, 4 like that. So this is 100% continuous data. But when we discuss about the class width in here, what is the class width in here? What is the class width in here? 1. When coming to here, class width is 0.2. When we come into here, class width is 0.3. So we have to understand this is the second type. What is mean by second type? Second type mean this is, okay, this is continuous data and non-equal class. Non-equal class. So this scenario, only one thing we have to change. We can't draw the histogram with the frequency. So we have to calculate the another term. It is called frequency density. Frequency density. So what is mean by frequency density? Frequency, how we can calculate frequency density? We have to divide frequency by class width. Class width. As example, in here, frequency is 2, class width also 1. So frequency density is 2. But when we come to here, frequency is 6, class width is 0.2. Then frequency density is 30. So like that, we have to calculate the frequency densities. Then as previous, we have to draw the histogram. Horizontal axis, we can take that lung volumes, but in the vertical axis, we have to take the frequency density. That is the only difference between histogram type 1 and type 2. Right. Okay. And this is the equation. Frequency density is equal frequency divided by width. You can see here, these are the frequency, these are the class width. Okay, then frequency divided by class width, then the frequency density come. Okay, frequency density 230, like that it is come. Right. When we see this one, okay, what is the class width? What is the class width in here? 4. When we come into here also, class width 4. Class width means we have to deduct the front number from the last number. 15 minus 11, 4. 20 minus 16, it is also 4. So in this case, we can observe class width are equal, but is it continuous data? You can see, okay, end up with 10, the next class start with 11. End up with 15, next class start with 16. So this is not continuous data. So that kind of situation, okay, what we have to do, mathematically, we have to do some activity to continue the data. What is the activity? In here, 10 to 11, gap is 1. So what we have to do, the gap, we have to divide by 2. When we divide the gap by 2, because gap is 10 to 11, 1, 15 to 16, 1, 20 to 21, 1. So that means 1 divided by 2. Then the answer is 0.5. Now, artificially, we have to prepare the classes. How we can prepare the classes? 0.5, we have to deduct from the front number. 0.5, we have to add into the n number. So when we deduct 0.5 from 6, 5.5. When we add 0.5 into 10, 10.5. So when we come to this class, 11 minus 0.5, 10.5, 15 plus 0.5, 15.5. Now what happened? That uncontinuous data, mathematically we convert into the continuous data. 10.5, 10.5, 15.5, 15.5, 20.5, 20. So now, as previous, we have to draw the histogram. Horizontal axis, x-axis, we can consider that artificially prepared classes. Then frequency we can take into the y-axis. So this is the third type. Third type mean, okay, what is the third type? Continuous, sorry, non-continuous data and equal class. Right. So what is the fourth one? Okay. Now I'm typing all the possibilities in histogram in here. The first one is, okay, continuous data and equal class. Equal class. Then second one, continuous data and non-equal class. So at that time, we have to calculate the frequency density. Then frequency density, we have to take into the horizontal y-axis, vertical axis. Then third one is non-continuous data and equal class. So in this situation, we have to convert what is called that non-continuous data into continuous by doing that mathematical activity. The fourth type also, there can be some histograms, non-continuous and non-equal class with also. So what we have to do, we have to take combination of type 2 and type 3. So non-continuous data, by doing this activity, we can convert as a continuous data. Because of the class with unequal, we have to take the frequency density also. Then we can draw the histogram. So I think there is a clear idea now you have regarding the histograms. So because of that, I would like to move the second problem analyzing tool. That is called Pareto chart. Please see the definition. Pareto analysis is a formal technique useful where many possible causes of actions are competing for attention. We know when we talk about the problem, there can be several causes. So we have to identify what are the critical causes we have to address. Because giving answer for all causes, that is not practically possible. Okay. But if it is possible also, it is meaningless. No need to solve all the small causes also. Okay, when we talk about the Pareto analysis, there is a theory behind that. Pareto analysis use the Pareto principles, also known as the 80-20 rule. Some people telling this 20-80 rule, that is not an issue. So, which was coined by Italian economist Vilfredo Pareto. So, this concept introduced by Italian economist. That person's name Vilfredo Pareto. Because of that, as a respect to that person, we call this concept as a Pareto analysis. That means if there are 100 courses, if there are 100 courses, okay, we have to select critical 20% of courses. When we solve the critical 20% of problem, okay, according to the theory, 80% of the problem will be solved. That is the thing. So if 100 courses, 20 courses are the critical courses. When we solve that 20 courses, when we talk about the total problem, 80% of solutions we can expect. We can expect. Okay. So if there is a 10 causes, that means 2 critical causes. When we solve that 2 critical causes, 80% of problem will be solved. This is introduced by Italian economist Vilfredo Pareto by conducting several researches. Okay. Right. Okay. This is simple example to explain you how to draw the Pareto chart. Okay. You can see in here. This is actually one production line last month type of defects with the quantities. You can see side seam, bottom hem, collar attached, sleeve hem, cup covering like that. Okay, this is the frequency mean how many defects. Then total defects was 144. So step number 1, when we draw the Pareto chart, okay, step number 1 is we have to create this data in a descending node. Arrange data in descending node. Descending. So now you can see this table. The highest one is bottom hem, 67 number of defects they found. The next one armhole, likewise from highest number to lowest number. That is called the descending node. Right. After we prepare the descending node, after we arrange the data into descending order, okay, then next step is, okay, we have to calculate the individual percentage. What is the step number 2? Calculate individual percentage. Step number 2, calculate individual percentages. How we calculate individual percentages? It is very easy. In here 67. So 67 divided by total number of defects are 144. So percentage is, okay. So we have to multiply this by 100 to take the percentage. Then answer is 46.54. So likewise, we have to calculate all the individual percentages. Right. After we calculate individual percentage, the next step is we have to calculate the cumulative percentage. How we can calculate the cumulative percentage? In here, 46.5. So cumulative percentage is 46.5. When we come into here, 46.5, we have to add into 16.7. Then cumulative percentage, 63.2. Then 63.2, then 62 for 3.2, okay, 63.2, we have to add with 11.8, okay, then this is the cumulative percentage. So likewise, we can calculate cumulative percentage for all the defects. The final cumulative percentage has to be 100 because when we calculate the individual percentage, the total is 100. Right. Now, all the pre-activity is completed. Now we have to draw the histogram, Pareto chart. Okay. It is like this. You can see. Normally, horizontal axis, we represent the type of defects, category. Then y-axis, we consider the frequency. By considering frequencies at the type of defects, we can draw this type of bar chart. As example, bottom hem, 67. Then side seam, 24. Zipper outline, 17. Cuff covering, 11. Like this bar chart we can prepare. We have to keep in our mind, when we talk about the histogram, we told don't keep the space in between 2 bars because that data confuses. But when we draw the Pareto, purposely, we have to keep same space in between each bar. So you will realize why it is required. After we draw the bar chart, then we can draw another x-axis. It is illustrate the cumulative percentage. Now, by considering cumulative percentage, okay, when we consider the bottom hem, cumulative percentage is 45.3 or something. So we are marking dot here. When we come into side seam, you can remember the cumulative percentage was 63.2. Then how we can mark? We take the center line of this bar, center line. Then we take the 63.2 from this axis. Then what is the intersecting point? So we can mark this is the point. This is the point. So likewise, we can mark and we have drawn the very smooth freehand curve that is called cumulative curve. That is called cumulative curve. Cumulative curve. This is cumulative curve. Now, Pareto chart complete. Okay. So now we have to understand how we can take the decisions. As example, okay, you can see in here. If you want to solve the problem 80%, we have to project that 80% into the cumulative curve. So whatever the intersect point, we have to project into the x-axis. That means if we want to solve the 80%, we have to solve what are the critical issues, bottom hem, side seam, and zipper outline. We have to solve. So if we want to solve 90%, okay, example, we have to project 90%. Okay, it may be like here. Then we have to project into. So if we want 90% solution, so how many problems do we have to solve? 1, 2, 3, 4, 5 problems we have. So other way also we can think, okay, according to our organization capability, we can solve only the bottom. Then what we have to do? From the middle of the space. So that's why I told you to keep the same space. Project into this side. Then from the intersect point, we are projecting to this. So it may be around 50% solution we can get if we solve only the one. So likewise, we can take the decision by using Pareto chart. So I think now you may have some idea about the histogram as well as the Pareto chart. So we'll move into the next one. It is called cause and effect diagram. But I would like to tell some people call this fishbone diagram. Some people also call this Ishikawa diagram. All names are correct. Okay. Why we are calling Ishikawa? Because the Japanese person Ishikawa found this concept and introduced this concept. So because of that, we are using Ishikawa. Why we use fishbone diagram? It is like a fishbone. Okay, I'll explain this in future. So because of that, sometimes we are telling this fishbone diagram also. Right. So what is the expectation from cause and effect diagram? The fishbone diagrams identify many possible causes for an effect or problem. It can be used to structure a brainstorming session. It immediately sort idea into the useful categories. So when we draw the fishbone diagram, usually we are conducting that activity through the brainstorming sessions. Okay. So I'll explain a little bit about the brainstorming in future. Then whatever the idea coming from the audience, whoever the person participate for the brainstorm. So through the fishbone, we are categorizing. Okay. So this is like a fishbone. Now you can see the just in here put the quality problem. So whatever problem we can put in here. So this is the head of the piece. So usually we are writing the problem on the head of the piece. Okay, this is the head. Then axes, you can put any axes, but it should be material, machine, method, and man. That means 4M we have to come. 4M. You know 4M means man, machine, material, methods. that 4-axis is must. Other than that, you can put any other axis. It may be measurement, it may be environment, so whatever. So this is the simple fishbone diagram. Now, as example, okay, this is one of the example. Now you can see, okay, there is a problem here. I'm not going to talk about the problem. Then through the brainstorming, there are several causes came into the axis. Then through the fishbone also, rather than what is called separate into the different categories, we can find out the what is called that we can focus something, we can prioritize something. Most likely cause we can find out. So how we can find out most likely cause? First, we have to identify what are the axis major issues. That means the large number of causes included. In here, I think this one, people. Okay, if we select the people, so our first priority we have to give to solve these causes. Then if we have data, okay, if we have data, by using data, we can select the priority, we can give the priority also. We can prioritize the causes also. That means first, what we have to solve. Second, what we have to solve, like that. So if we haven't data, we can do some survey. We can collect some sample. We can give some questionnaire. So based on the questionnaire, we can analyze. So likewise also, we can prioritize. If we haven't data, if we can't conduct the survey because if we haven't that much of time, then we can go for the vote. Vote. So whoever the people participate for the brainstorming, we can conduct the voting session. From the voting, we can select the prioritize course. That is called most likely cost. Most likely then it is not relevant to the fishbone, but I would like to add something. From the most likely cause, if you want, you can find out the root cause also. So from most likely cause to root cause, okay, we have to go through the 5 why analysis. We have to go through the 5 why analysis. 5 why analysis. So today I'm not expecting to talk about the 5 why analysis. Just I added in here. So from the fishbone diagram, we can segregate causes into the different part. And also by using these 3 mechanisms, okay, we can find out the most likely causes. Right. So now you may have some small idea, rough idea about the fishbone diagram, cause and effect diagram, hypnotic Ishikawa diagram. So we'll move into the next tool. It is called defect concentration diagram. This is very simple tool, but this is very powerful tool. A defect concentration diagram is a picture. This is a picture of the unit showing all relevant view. Now you see our product is this. So the front view and the back view of the product, okay, we have to print on the at least in the A3 size, and we have to give this picture into the N-line quality control. Then when they check, okay, if they have found some defect in this area, they have to mark the defect. Next defect also like this. Okay. Next defect maybe they found in here. Next defect they found in here. Another defect they found in here. Another defect found in here. Another defect likewise. Now what we can take from this? Whoever the person need to solve this issue, without observing, without analyzing data or anything, from one snapshot, okay, that person can take idea, okay, in this production unit, Okay, there is a problem relating to this area. This is called bottom area, this area. So directly that person can drive into that area and give the solution. So this is visual tool. Everyone can understand. Problem coming to the surface. So when the problem coming to the surface, the constructive pressure generated from the problem solver and directly they push into that person into the problem happening. So that is the defect concentration band. This is very simple. Some people call this Miesel chart. Some people call this Miesel chart. Miesel charts. That is also keeping in your mind. Right. Then already we have discussed about the 4 types of problem analyzing tools. I am telling problem analyzing tools. The first one was histograms. The second one was Pareto charts. Third one, cause and effect diagram. Fourth one, just now we have discussed defect concentration diagrams. Defect concentration diagram. Okay, right. Now we are moving to the fifth one. Fifth one. What is fifth one? That is called control chart. The definition of control chart, a statistical tool to determine if a process is in control. So control chart we are using to understand our process is in control level or is it out of control. There are 2 types of control chart, variable control chart and attribute control chart. So what is mean variable control chart? If anything we can measure by using some unit, that is called variable. As example, weight, height, speed, volume, length, whatever thing we can do. Okay. So what is mean by attribute? Attribute mean, okay, variable means something we can measure. Variable mean, okay, something we can measure. Something we can measure. Then attribute mean, okay, that is subjective. That is qualitative. Qualitative something. It is very difficult to measure. Maybe the appearance of the product, okay, we can take as an attribute, right? But we can draw the control chart for the variable as well as the attribute also, right? When we talk about the control chart, there are few terms we have to keep in our mind, okay? Usually we are talking about out of control. Out of control means the process may not perform correctly. Then we talk about the in control. That means the process may be performing correctly. Then UCL mean upper control limit. LCL mean lower control limit. Then CL, it is called mean also, that is average. So these terms we have to keep in our mind. Out of control, in control, upper control limit, lower control limit, average value. If not center line, we can tell the mean also. Right. Okay, this is simple example. There are 10 number of students here. That 10 students, the individual person's height we can measure, we measured by using inch. Okay, this is included in. So when we draw the control chart, it is simply like this. This is the control chart, simple control chart. Okay, it's like this. This is center line. This is lower control limit. This is upper control limit. Upper control. Okay. So whatever the data points, we have to include in between these area. So based on that, we can decide it is out of control or in control. Okay, we'll discuss that in later. So it is very important. First thing, we have to calculate the center line. The mechanism to calculate the center line is, this is the equation we can use. Okay, center line. Okay, what is the equation? Equal summation of x divided by n. That is same as mean also. We can use the Greek letter mu to denote the mean. So summation of x mean, these are the x terms. So we have to take we have to add each one. We have to take the total number, total amount. Then we have to divide by n, mean number of x. So we can calculate the mu, if not center line, by using this simple equation. Okay, center line. Now you can see in here, okay, the total is 690. So 690 divided by 10. So what is the center line? Center line is 69. 690 divided by 10. So it's equal to 69. So it's equal to center line. That is the center line. After we find out the center line, now we have to find out the upper control limit and lower control limit. Okay. So again, I am drawing in here. This is the control chart. Now already we know center line. Okay, center line is 69. Center line equal 69. Now we have to find out upper control limit as well as lower control. So according to the statistics, the upper control limits located and the lower control limit located the same distance from the center line in upward and downward. That distance we call standard deviation. So standard deviation we denote by sigma. Sigma, that is the degree. So there is an equation to find out the sigma. You can see this is the equation we can use to find out the sigma. So now we have to do what we have to do. We have to calculate the sigma. So it is also very simple. So if we want to calculate the sigma, we have to calculate first x minus mu terms. So x mean these terms, mu mean our center line, 69, mean. Then 65 minus 69 in here, because mean 69. So 65 minus 69. Then what is the answer? Minus 2. In here, 70 minus 69, 1. 80 minus 69, 11. So likewise, we can find out x minus mu terms. Then we have to take x minus mu squared, because what is our equation? I just type in here, equation I write in here, summation x minus mu squared divided by n minus 1. Then we have to take the square root of all these terms. It is equal to the sigma. Is the equation. So because of that, in here, I am finding x minus mu squared. So x minus mu minus 4. When we multiply by another minus 4, that means the square, it is 60. This is 1 by 1, 1. 11 by 11, 121. 9 by 9, 81. Minus by minus plus. So these are the x minus mu terms. Now x minus mu squared summation. So we have to add all these terms and we have to take the summation. That summation, okay, it is around 510. The summation is 510 in this example. Now we have to divide by n minus 1. N minus 1 means there are n terms here. N is 10. So 10 minus 1 means we have to divide by 9. We have to divide by 9. That answer, we have to take the square root of that. Square root of that answer we have to consider. Okay. The x minus mu squared summation is 510. Divided by n minus 1 is 9. The equation is 56.7. So we have to take the square root of 56.7. So we can consider that scientific calculator. From the scientific calculator, we can take the square root. It is maybe 7 point something. Okay, 7.6 or something. Okay. It can be changed, but I just by observing that 56.7, I am telling it is maybe 7.6 something. So our sigma value is 7.6. Okay. Now what we have to do, we have to find out upper control limit and lower control limit. Okay. In here there is a issue, not the 56.7. We have to put, okay, we have to put 7.6 because square root value you have to put 7.6. So based on that, okay, 69 at, okay, center line is 69, upper control limit, center line plus sigma. Center line is 69, sigma is 7.6. So what is the answer? Okay, we'll add just now. What is the answer when we add 69 plus 7.6? 76 point. Upper control limit is 76.6. Then what is the lower control limit? Lower control limit equals center line minus sigma. Center line is 69 minus 7.6. 61.4. So center line is 69. Upper control limit is 76. It's like this. It's like this. Center line, it is 69. I just put, okay, center line. Then upper control limit is upper control limit. Upper control limit, that is 76.6. 76.6. Then the lower control limit, okay, is the lower control limit, okay, lower control limit, that is 61.4. 61.4. Now all the x terms we have to mark in here. The x terms, you can remember that height of the students. So based on that, you can draw the control chart. It may be like this. So it is very good if you can use graph sheet, then proportionally we can mark. Okay, this is the simple histogram, control chart. Control chart. Okay, right. Now, okay, when we talk about that control chart, it is only one sample, 10 people, one sample. But in here, you can see the main sample here. There are subsamples also here. Main sample, 10 main samples, 5 subsamples. It's like this. First hour, we are measuring 5 garment. Second hour, we are measuring another 5 garment. Third hour, we are measuring another 5 garment, like that. So that kind of situation, we have to calculate the X bar as well as R. How to calculate the X bar? We have to take the average of these 5. 10, 11, 10, 12, 11, we have to add, divide by 5, then 10.8. So likewise, we have to take the average. R mean range. Range mean the difference between largest number and the lowest number. In here, largest number 12, lowest number 10. So difference 12 to 10 difference is 2. When coming to here, largest number 13, the lowest number 10. So difference is 3. So already we have calculated X bar values. Then we calculate the R value. X bar, that bar mean average. So we take the subsample average. Then we have to calculate, okay, we have to calculate X double bar. So X double bar is the center line of the X chart. Then we have to calculate the R bar. R bar means center line of the R chart. Because when two samples available, okay, main sample and subsample, what we have to do? We have to take, we have to draw two charts, X chart and R chart. Okay, X chart and R chart. So when we draw X chart, we have to take the center line as X double bar. That means we have to add all these X bar value and divide in number of 10. So 10, we have to divide by 10. Then we can take the X double bar. So R bar, we have to calculate the range. Then we have to add all the range value, divide by 10. Then we can take the R bar. Then very important thing is, okay, now you can see, okay, this is the X double bar, sum of all X bar divided by total number of sample. Then R bar, sum of all R divided by total number of sample. So little change in this equation. This should be X double bar. Eh? This should be X double bar. X double bar. This is also X double. Now there is a standard table in a statistic. So what we have to do, when we calculate the upper control limit, X double bar plus A2 R bar. Now we know about the X double bar because already we have calculated X double bar. Already we have calculated the R bar also, but we don't know about the A2. So by using this standard table, you can see in here, okay, number of unit in a sample. So when we consider the main sample, how many subunit, subsamples? In our case, 5 subsamples. 5 subsamples. So because of that, we have to consider that line number 5. This. So what is the relevant A2? What is the relevant A2? A2 is 0.5. Okay. Then we know the A2. So we can calculate upper control limit also. X double bar we know, A2 now we know, R bar we know. So in the X chart, we can calculate the lower control limit also. When going to draw the R chart, so upper control limit, lower control limit, R bar already we know. We want to find out D4 and D3. In here, you can see D3 is 0. Okay, D3 is 0. D4 is 2.1. So we can calculate the upper control limit and lower control limit of R chart also. Okay, right. This is very clear. Then based on that, we can draw the graph. Okay, this is the X chart. This is the R chart. So lower control limit, center line and upper control limit here. In here, lower control limit, center line and upper control limit also here. The X chart we are usually drawing by marking the X bar because this is center line is X double bar. So we are marking the X bar values in here. Because from this chart, we can understand process is control or not control. From the R chart, it is like a line chart. from the R chart, we can understand if the process is controlled also, when we consider that 5 samples, okay, what is the range? What is the difference between largest and the lowest? So if it is controlled also, there is a risk if the range is high. That idea we can take from the R chart. R chart. Okay, right. Now, okay, it is important to know about how the process is out of control. Now you can see in here, one or multiple point outside the control. When we draw the control chart, okay, I'll draw and explain, then it is very easy to understand. If this is our control chart, this is center line. This is upper control limit. This is lower control limit. When we draw the chart, okay, then our chart is like this, control chart. If at least one point going to the outside of the control limit, so our process is not control, out of control. Then what is the second one? 8 point in a row above the average value. This is not only above or below. If 8 consecutive point, going to above or, okay, 1, 2, 3, 4, 5, 6, 7, 8. This is the center line, above the center line. If not 1, 2, 3, 4, 5, 6, 7, 8, then only start the moving into both direction. So this is also out of it. Then multiple points in a row near to the control. If the point is not going to outside, but multiple points near to the control limit mean that is also a reason to uncontrol, out of control the things. Okay, that is also out of control. So these are the 3 situations we can consider about the out of control. We can consider about the out of control. Okay, right. Now, I think you may have some idea about the control charts also. You may have some idea about the control charts also. So now I am moving to next one. Scatter diagram. So this is the definition. To identify the correlations that might exist between a quality characteristic and a factor that might be driving it. This is not only the quality characteristic. When we consider any kind of 2 factors, as example, if we want to find out the correlation between efficiency and damage, then we can draw the scatter diagram. If we want to find out the correlation between efficiency and the absenteeism, then we can draw the scatter diagram. Okay. So scatter diagram, this is simple one. You can see, I consider 5 students. Okay. This is the height of the student. This is the weight of the student. Now I can prepare this kind of classes. As example, student A, okay, height 71. When the height 71, weight is 175. Student B, height 68. When the height 68, okay, the weight is 160. Likewise, I already prepared the classes. Then, okay, what I can do, I can draw that classes on the Cartesian plane. This is called Cartesian plane. Then I can draw the best fit line. It no need to go all the points. That is best fit. I'm drawing like this. This is the best fit line. It is called best fit line. Best fit line. So based on the best fit line, we can talk about the correlation between these 2 terms. Okay, correlation between these 2 terms. This is another example also. Okay, you can see, no? I'm marking the classes on the Cartesian plane. Then we can do the best fit line. So based on the best fit line, there are several types of correlations you can see. This is called positive correlations. If the best fit line come into this direction, that is called negative correlations. If we can't draw the best fit line, that means there are several best fit line. If we want, we can draw. That is called no correlation. It is called scatter. Even the positive correlations, if the data points lies very near to the best fit line, that is called strong positive. If the data point lies little bit what is called little bit away from the best fit line, that is called weak. So strong positive, strong weak, no correlation. Likewise, weak negative, weak strong, weak strong. So how we can take positive as example? If one parameter increase, okay, the other parameter also increase, then this kind of relations come. It is called positive correlation. In this scenario, one parameter increase, but other parameter decrease. Then this kind of correlations come. So that is called negative. Again, I am telling, when one parameter increase, improve, other parameter also improving, that is positive. When one parameter increase, other parameter going to reduce, that is called negative. These are the correlations which we can found through the scatter diagram. This is another example. You can see, okay, this kind of thing. 12 view fields we can consider. These are the benchmark for that 12 view fields. These are the history mark of that 12 fields. So we can take history into x-axis. We can take French into y-axis. It is not any hard and fast. If you want, you can take French into x-axis, history into y-axis. Then we can draw the scatter diagram. Then by using the scatter diagram, we can understand the correlation, and also we can predict. As example, if some person, Adam, the person is scored 60% in French, but he is not participate for the history. Then we can predict, okay, Adam got 60% for the French, then we have to draw the projection line into the best fit line. Then whatever the intersect point we can project into the history axis, then we can take the predictions also. We can take the predictions also. Last one is check sheet. This is very simple. Check sheet means if we want to collect any data for the analysis purposes, whatever the format you are preparing, that is called check sheet. As example, I want to calculate BMI of the class member. As example, we think we have 10 members, 10 class members. Now, I want to prepare the check sheet. So there is one small format. I'll prepare like this. I want to take the BMI. This is the equation. So weight in kilograms. So I just put name, 10 people's there. Then I want weight of each people. It should be kilogram. Then I want height. It should be meter. Height, okay, it should be meter. Meter. Then according to the equation, I want square root of height. So I'm taking the square root of height also. I just put another column. Height is square. Okay. Then BMI. So this is the simple format I have to prepare. That is called check sheet. Check sheet for that particular purpose. Because I want to calculate BMI, no? So this is the check sheet. So if you want to collect daily efficiencies, daily damage percentage, then if you want to calculate weekly average efficiency, average damage percentage, so you have to prepare the format based on your requirement. You have to collect some data, you have to do some analysis also, calculations also. So that is called the check sheet. Okay. Okay, right. So up to now, we have learned about 7 types of problem analyzing tools. You can remember histogram. Why we want to draw the histogram? What is the purpose? Used to illustrate the frequency distribution of continuous data. The second one is Pareto chart, used to select the critical issues to be solved. We have to find out the critical 20%. Cause and effect diagram, used to identify the possible causes. Then we can categorize the causes, as well as I would like to tell, we have to find out the most likely cause also from the Fishbone diagram. Then defect concentration diagram, used to get the understanding of problem happen in place. Then it is visual pose, visual illustration. The whoever the person need to take the actions within flash, okay, within one snapshot, it will give the direction. Then control chart, used to identify whether the process is in control or out of control. Okay, you can remember, if we have main samples only, we have to do the normal control chart. If we have main sample and subsample, we have to draw X chart and R chart also. Scatter diagram, used to identify the correlation between two factors. Check sheet, used to collect the data for analysis. So check sheet, whatever the format you can prepare based on your requirement. So I think now you may have good idea, good knowledge about the 7 type of problem solving, according to myself, problem analyzing tools. Okay. So this is the today expectation of this video, because I thought to give some summarize explanation view regarding that 7 type of problem analyzing. So when we're going to do PDCA analysis, a type of problem solving, so whatever the problem solving related activities, you can use these 7 type of tool to analyze the available data. So I'm expecting to meet you with another video. I think you may have got some good idea about this. So we'll meet again. Thank you very much.